Hello, all my wonderful people. Welcome back. We get to do 4 or 5 today, which is all about right triangles. How can I show that two right triangles are congruent? So we have quite a few theorems. Sorry, not theorems, but new vocabulary. It's not really new vocabulary. We're just going to review this vocabulary, okay? And then we're going to learn one more condition. So far we have side, 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 angle, side, right? Angle, side, angle, 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 side. And then we're going to add a fifth one today, which is the hypotenuse leg, HL. And then, so that's what we're going to do. And then we're going to use all of our criteria that we have to prove that two right triangles are the same. So let's just go ahead and jump to this new vocabulary and the theorems so that we can get a move on example 1. So go down to the end of your packet and let's go over this vocabulary. Okay, so let's start with our first term, which is acute angle. Hopefully this is review. But an acute angle is an angle between 0 and 90 degrees. So anything between 0 and 90. So there would be my acute angle, right? It can't be 90 because 90 is a right triangle. And it can't be 0 because then that's not an angle. So it has to be between 0 and 90. Hopefully that's pretty quick and easy here. So let's continue on. Okay, so here we have some more. Hypotenuse. So the hypotenuse is the longest segment in a right triangle. So if I have a right triangle, almost a right, yeah, there's my right triangle, okay? The hypotenuse is always the one that's across from the right angle. So hypotenuse. It's always across from the right angle. It's always the longest side in a right triangle. Okay, so right here, the segment opposite the right angle in a right triangle. If you don't have a right triangle, you don't have a hypotenuse, okay? And then your legs are the other two sides in a right triangle. So there's my right triangle, right? This is my hypotenuse. So then this is a leg and this is a leg. And that's going to be really important because we're going to be using these words quite a bit, and so it's important that you know what it means, right? So the hypotenuse is always across from the right angle, and then the two legs are the other two sides. Again, if you don't have a right triangle, you don't have legs, okay? And you don't have a hypotenuse. Okay, so Pythagorean's theorem is just a little review here. We have talked about it already this year, but just a review of the Pythagorean's theorem in a right triangle, more or less. It's a squared plus b squared equals c squared. More importantly, c always has to be the hypotenuse. So really, more importantly, it's your leg squared, one of your legs, it doesn't matter which one, and then your other leg squared, and then c always has to be the hypotenuse. And that's the most important part here, okay? A and b can be switched around, whatever, but c has to be the hypotenuse. And then the last one here, is just a right triangle. So it's just a triangle that has a right angle, right? So any triangle, boom, here's a triangle. If it has a right angle, let's call this A, B, and C. If it has a right angle, it is a right triangle. And something also special that happens is that angle A and angle B are acute angles. Both of those angles are less than 90. Okay, so both of those angles have to be less than 90. Okay, hopefully nothing too mind-boggling on those terms. Let's look now at the next page, which is our theorems and postulates. And the last theorem and postulate that we're going to look at is this one, hypotenuse leg. Okay, so hypotenuse leg, this only works on right triangles. We have to make a note of that, okay? So only works in right triangles. If you don't have a right triangle, then you cannot use HL, okay? Right, because there is no hypotenuse if you don't have a right triangle, and there is no leg if you don't have a right triangle. So in order to even have a hypotenuse and a leg, you have to have a right triangle. So here, if I draw a right triangle and another right triangle, boom, boom. I'm just going to label this A, B, and C, and then D, E, and F. My pin's real jumpy today. Okay. So what this means is, first of all, I know it has to have a right triangle, like it has to have a right angle. So that's automatic. So what this is saying is, if I know that the hypotenuse in both triangles are the same, so if I know that AC and DF are the same, okay, so that's the hypotenuse part, and I know one leg is the same. So let's say this one, this one, okay. It could have been A, B, and D, E as well. I just chose this one because why not? Okay. So in this triangle, I know that there's a right angle. I know that the hypotenuse is the same in both triangles. And I know that one of the legs is the same in both triangles. So by HL, I can say that these triangles are congruent. So I can say that triangle ABC is congruent to triangle DEF by HL congruency, right? I am officially able to say that these two triangles are the same by hypotenuse leg. This tells me that A, there's a right angle, B, that the hypotenuse in both triangles are the same, and that a leg in both triangles are the same. So that's what we're going to focus on today, is looking at HL and how can I find congruence in these right triangles. Okay, so let's go ahead and go back into our note packet and find 4-5, and we're going to start with example 1. Okay, so let's look at example 1 here. Example 1 says, when any two pairs of corresponding sides are congruent, can you show that two right triangles are congruent? So two pairs of corresponding sides. So that could mean that CB and EF are congruent, or that could be that AC and DF are congruent. So there's that. So if I have both legs, right, then I have side, angle, side. Do we see that? So if two legs are known, right? So if two legs are known, I have triangle ABC is congruent to triangle DEF by side, angle, side. Congruency. Okay, I have a side, then an angle, then a side. Okay? So if that happens, great. If I know that a leg and the hypotenuse, okay, so if one leg and the hypotenuse are known. Well, I can use Pythagorean's theorem to find this last leg, right? So we can say that then Pythagorean theorem shows the other leg So, all right, so let's think about this. I'm going to use my a squared, right, plus b squared equals c squared. That's my Pythagorean theorem. I can use that to find the final leg, this guy right here. That means that I have all three sides. Well, if I have all three sides, then I can say that triangle ABC is congruent to triangle DEF by side, side, side. Congruency. So what we've just kind of shown is, hey, even if I know a hypotenuse, let me get rid of this. If I know the hypotenuse and the leg, I could find the other leg and it would all be congruent, or I can just use HL, right? Which now tells me as long as I know the hypotenuse and a leg, then I can go ahead and say that my two triangles are congruent. I don't have to go through the whole process of finding the third side. Okay, so let's look at an example here. So this one says, can you show that two right triangles are congruent when any one pair of corresponding acute angles is congruent and any one pair of corresponding legs is congruent? So let's look. So I have two right triangles. So the easiest way, if you don't know how to do something, the easiest way is to draw it, right? I'm going to draw it. So A, B, C, D, E, F. Okay, and I know that these are right triangles because it tells me show that two right triangles. Okay, so this says, can you show that two right triangles are congruent when any one pair of corresponding acute angles is congruent? So when any one pair of corresponding acute angles is congruent, so let's just pick an angle, boom, boom, and any pair of corresponding legs. So let's say this leg, right? It's a leg. Can I say that these two triangles are congruent? And hopefully we see that it's angle, side, angle, right? So yes, because of angle, side, angle, congruency, right? But that's just one example. What if I drew a different one? All right, oops, that's not how I labeled it before. Sorry. Okay, A, B, C, and D, E, F. Okay, so now, again, they're right triangles. And let's say I know the same angle, but now let's say instead of this leg, instead of AB, I know BC and EF. So same angle, different leg. Does that work? And here, hopefully we see we have angle, then a side. So yes, this also shows that they are congruent by angle, angle, side. So if I have a right triangle and I know one of the acute angles is the same, and I know one of the sides is the same, one of the legs, excuse me, one of the legs are the same, then either way I can show that the two triangles are congruent. Okay, so let's look at another example as we just cruise through this. So this one says, can you show that the two triangles are congruent and explain? Okay, well, I have two right triangles, so that's neat. So we've kind of already proved the hypotenuse leg theorem, so we can keep going with that, proving it, or we can just use it, right? I have a right triangle. I know that my hypotenuse is the same in both triangles because both the hypotenuses have two tick marks. And I know one of my legs is the same in both triangles. So yeah, I can, right? We can say yes, triangle TUV is congruent to triangle WXY by HL, right? It's a right triangle. I know the hypotenuse is the same, and I know one of the legs is the same. So I can use HL. We're not actually gonna do example 2. Let's skip over it. I don't think that there's enough. I think I messed up when I was typing that in. So we're gonna skip over that, sorry. Okay, so here, the question is, what information is needed in order to use HL? Okay, so in order to use HL, I need to know that the hypotenuse is the same in both triangles. Well, in this triangle, right, the hypotenuse is always across from the right angle. So here my hypotenuse is 9, but here I don't know what my hypotenuse is. So I would have to know that PR is equal to 9, right? I would have to know that PR is equal to 9. Okay, and then the other thing is I have this leg that's 5, but over here I don't know what this leg is. So I would also have to know that MN is 5. If I know those two pieces of information, right, if I know that PR is 9 and MN is 5, then yes, I can say that the two triangles are congruent, right? Because it's a right triangle. The hypotenuse is the same in both, and one of the legs is the same in both. So this is the information I would need to know in order for these two triangles to be congruent by HL. Okay, so I want you guys to try one here. So try this one. What information would be sufficient to show that the triangles are congruent by HL? So what information would you need to know? Go ahead and try it, hit pause, and then when you're ready, hit play. All right, so let's check how you did. It says what information would be sufficient, right, to show that the triangles are congruent by HL? Well, here, I know that my hypotenuse is 10. Here, I know my hypotenuse is also 10, so that's good. And then here, I'm given that my leg is 6. So here, I would just need to know that my leg is 6. So hopefully we just got that all we would have to know here is that YZ is equal to 6. Okay, and then I would know that my hypotenuse lengths are the same and my leg lengths are the same. So the last problem we're going to do here is we're going to do a proof using HL. So let's see if we can get it all in one. There we go. Something like that. Okay, so let's look. This says write a proof to show that a triangle, is isosceles. So I'm trying to prove that this length and this length are the same. And when I look at this, I already know, it's already given to me that AE and AD are the same, right, with these tick marks. So then really all I have to find is this length of EC. I just have to prove that EC and DB are the same, right? Because if the top half is the same and the bottom half is the same, then the total is the same. So let's look at what we're given. I'm given that FD, F to D is perpendicular to AB. So FD is perpendicular to AB. So that's how we got the right angle here, and then also here too, right? I'm given that F to E is perpendicular to AC. FE is perpendicular to AC. And again, that's how I got that right angle and this right angle as well. I'm given that AE is congruent to AD, and that's something that we had already noticed, right, with these tick marks. And I'm given that FC is congruent to FB, which again, they gave me because of the tick marks. And I know all of these things because they were given to me, right? They told me. And I'm trying to prove that ABC, this whole triangle, is isosceles. Okay? Well, so what I'm seeing here is that I have 4 right triangles, right? So I have triangle AEF, so triangle AEF, right? I have triangle ADF, I have triangle E or FEC, FEC, and triangle FDB. Are right triangles. So I know that these are right triangles by definition of right triangle, right? They all have a 90 degree. So the reason here is by definition of right triangle. So I know that these triangles are right because they all have a right angle. It's real hard to write this small. Okay. All right, so I know that we got right angles going on. I also know I'm looking at AF, and AF is the same line in both of these triangles, so that I can say that AF in one of my triangles is congruent to AF in the other triangle, because it's the same line, right? This length right here in this triangle is the same as that length in this triangle. Okay, and that's called the reflexive property. Anytime you have the exact same side or angle, it's going to be the reflexive property. Okay, so if I know that I'm going to use 3 tick marks, this line is the same. I know the hypotenuse is the same in both triangles. And I know that a leg is the same in both of these triangles. So I can say that triangle, what order, AEF is congruent to triangle, what did I do, AEF? So ADF. I can see that those triangles are congruent by HL. It's a right triangle. I know the hypotenuse is the same in both triangles, and I know one of the legs is the same in both triangles. Okay? So since these two triangles are the same, that also means that this side is the same, right? That side's the same in both triangles. So I can say that FE is congruent to FD. Right? If the triangles are the same, then every part of the triangle is the same. And the reason that we use that is our CPCTC. Okay? If these two triangles are the same, let's draw them separately. Okay, so if I know that these two triangles are the same, because I know that this one and this one are the same, I know that this one and this one are the same. Okay, so if I can say that these two triangles are congruent, then that means that their third side is also congruent by CPCTC. Okay, so now let's look at these bottom triangles. And again, I'm going to draw them separately. So here are those bottom triangles where this one's a right angle, and this one's a right angle. And I'm given that these two sides are the same. And I just found that these two sides are the same. So now the question is, are these two triangles congruent? Well, they're both right triangles. I know the hypotenuse, right, is the same in both. And I know one of the legs is the same in both. So yeah, they are congruent. And I can say that triangle FEC, FEC is congruent to triangle FEC FDB. By HL. And remember our goal. My goal really here is to find this length and this length to prove that those two lengths are equal. Well, if the triangles are equal, are their lengths equal? Hopefully we say yes, right? Yeah. So if those lengths are equal and these angles are equal, then I know that this is an isosceles triangle. Well, if the triangles are equal, can I also say that this angle and this angle are equal? Yeah, right? So I can say that angle C is congruent to angle B. And really what we should say is angle ACB, right? ACB is congruent to angle ABC. And why can I say that those angles are the same? Well, they're in the same spot. They're in corresponding spots in this triangle. So if these two triangles are exactly the same, then these two angles are exactly the same. And again, that's when we use CPCTC, right? I know the triangles are congruent, therefore any corresponding part of the two triangles are congruent. Okay, well, if these two base angles, right now I'm going to just draw the whole triangle. And all I know right now, this is A, B, and C. All I know is that these two base angles are congruent. Is that enough information to say that this triangle is isosceles? And the answer is yes. Okay, so we can say that triangle ABC is isosceles. Okay, we can say it's isosceles, and the reason we have to go back to last unit is the converse of, actually that was lesson 4-2. Converse of isosceles triangle theorem. 4-2, which says, hey, if these two base angles are the same, then these two side lengths are the same. And the triangle is isosceles. Whew, right? That was a pretty big proof. Lots of stuff to look at. We have one more to do. I'm going to go ahead and clear this and scroll down. I want you guys to try this one. I know some of you are probably like, yeah, right, you know. But I want you to try it and just see if you can do it. And if you, right? And if you need help, hit play and see one step, and then hit pause again and try it on your own. But you're really not going to get better at these unless you give them a shot on your own. So I'll get you started here. It says, I want to prove that the two triangles are congruent. Well, what two triangles, right? I want to prove that JKM, so this triangle here, is congruent to KLM, which is this triangle here. So I'm trying to show that the left side and the right side are the same. Okay, so now that I know what I'm trying to prove, I can look at my information. I'm given that JL is perpendicular to KM, which means all of these angles are right angles. Okay? All of those are right angles. And I'm given that JK and KL are the same. So those are two things that I can write in the given. So the first box, right, should always be my given. So I'm given those two. And I'm given that JK is congruent to LK. That's given. Okay, so I want you to pause the video, see how you go on this, and then when you are ready to check your work, or if you need a hint or something like that, go ahead and hit play and get what you need out of this example. All right, so the next thing that I'm going to add is, because this is perpendicular, I know that all four of these angles are right angles. So I can say that angle LNK, angle JNK, angle JNM, and angle LNM are right angles. Right? So all of these are right angles, right? Right angle, right angle, right angle. And the reason I can say that is the definition definition of perpendicular. By definition of perpendicular, all of those angles are right angles. So then I can say that since all of these are right angles, I can say that all four of these are right triangles, right? So I can say triangle, same thing, LNK, triangle JNK. It's really hard to write this small, I'm sorry. Triangle JNM and triangle LNM are right triangles, right? Are right triangles, and that's, again, definition of a right triangle. Definition of right triangle. Okay, so now that I know that all four of these are right triangles, what I'd really like to prove is that JKN and LKN are congruent. So I'd like to prove that. And I'd like to prove that JNM and LNM are also congruent. So if I can do that, then that's enough information for me to be able to say that the whole triangle are congruent. So a couple of things that I notice here, KN, I'm just going to focus on these top two triangles. Okay, KN is the same in both triangles. So I'm going to say that KN in one triangle is congruent to KN in the other triangle. And that's the reflexive property, right? It is literally the exact same line. So therefore, it is the same. So now if I draw these maybe separately, maybe it helps to see it separately. So here are those two triangles. I know this angle is right and this angle is right. I know this side and this side are the same. And I know this side and this side are the same. So I know that the hypotenuse is the same in both triangles. And I know one of the legs are the same in both triangles. So I can say that these triangles are congruent. So I'm going to say that triangle LNK is congruent to triangle JNK. And I can say that because of HL. Okay, I know the hypotenuse and I know a leg. Well, if these triangles are equal, then I can go ahead and say that this side and this side are also equal. Okay, so I'm going to go ahead and put that down too. So I can say that JN is congruent to LN. And then the question is, why can I say that, right? If I know that the triangles are congruent, then I can say that any other corresponding part is congruent. And so that's where our CPCTC comes in, right? Corresponding parts of congruent triangles are congruent. Okay, so I've proved that the top two are congruent. Woohoo, right? Oops, that's not what I wanted. So now I want to kind of prove that these bottom two are congruent. So I'm going to draw them separately. I think that's kind of helpful. Okay. I know that these are right because of earlier. And I also just proved that this side and this side are the same. Okay. But I also know here, if I look up here, NM is the same in both. So I can say that NM in one triangle is congruent to NM in the other triangle, again, by reflexive property, because it is the exact same line. So I'm going to use two tick marks again. I can say those two sides are congruent. So now the question is, sorry, I totally got distracted. Now I look and are these two triangles congruent? And yes, right? I have side, angle, side, right? So I can say that triangle JNM is congruent to triangle LNM by side angle side. So what I've done is I've proved that these top triangles, right, these two top triangles are the same, and these two bottom triangles are the same. So what I'm looking at then is the whole triangle, like, right, is this triangle the same as this triangle? Okay, sorry. So what we've looked at, now is this solid line triangle the same as the dashed line triangle, right? I know that this, am I not writing? There we go. I know that this side and this side are the same because I've just proved it. Or, right, because, sorry, it was given to me. I now can say that JM is congruent to LM, right? Or did I already do that? Nope. So I can say that JM is congruent to LM because of CPCTC, right? Because these two triangles were the same, so therefore those two sides have to be the same, okay? And I know that KM and KM is the same line because of reflexive, and we've already talked about that. So what I actually can do now is say that these two triangles are congruent by side, side, side. I can say that triangle JKM is congruent to triangle LKM by side, side, side congruency. Whew, another long proof here, but you know, as we do more of them, they're going to continue to get more difficult and long, and right, and being able to piece things together. Now, I do want to make a point here that sometimes, you know, your thought process is different than mine, and so sometimes you might have things in a different order, or you might have phrased things differently, or things like that. As long as I can follow your logic, right, and your step and your reason, and your step and your reason, and your step and your reason, and I can follow it and it works, then I'm happy and it's good to go. Okay, so do the best you can. It does not have to be word for word for what I just did. But it does have to prove what you're trying to prove. And in this case, I was trying to prove that JKM was congruent to LKM. And I did that. There are other ways that you can do that, you know, other than what I did. And I'm sure next time I do this problem, I could even do it in a different way. So just know that there's not one exact answer here, as long as you prove what you're trying to prove. Okay, that is it for 4-5. Please, please, please reach out to a teacher if you need help. Let us know. It's super important that you get help when you need it, because we are just flying through this stuff, and I don't want you to get lost or to get left behind. Okay, you do have some 4-5 practice, and good luck, and we'll see you soon.